Every transaction is governed by mathematical forces pulling in opposite directions. Algebra dictates the final point where these forces lock into place. We can map this system using three fundamental nodes: the base cost price, the public marked price, and the final selling price. The seller drives the first vector. They require a profit, which functions as a positive mathematical force expanding upwards from the base cost price. This document defines the buyer's opposing vector. A discount is a negative term that strictly operates downwards against the marked price. The final selling price is the inevitable equilibrium point where these two opposing vectors meet. Mastering pricing strategy requires mapping the specific geometry of this equilibrium rather than relying on isolated formulas. Let's model this algebra on a single geometric continuum tracking total value. This chart establishes our baseline. Marked price is the absolute ceiling, the total length. Applying a discount shears a segment away, defining the selling price boundary. In response, cost price expands upwards a profit margin until perfectly aligned. Because the selling price serves as a shared mathematical coordinate, we can link the seller's profit to the buyer's discount without referencing an absolute dollar amount. We can translate this visual equilibrium directly into formal algebraic equations. Looking at these notes, selling price is defined algebraically as 100 minus the discount percentage multiplied by the marked price. Setting the calculations equal to that selling price yields a derived formula, explicitly linking base cost price to final marked price. Mechanically, the ratio places the remaining fraction of the marked price over the expanded value of the required profit. This equation allows a retailer to reverse engineer their maximum allowable discount based on their strict minimum required margin. The structural math still functions even if the absolute base cost price is entirely unknown. Since selling price links both sides, we can isolate the ratio of marked price to cost price. The source text uses this to find the required percentage markup strictly from the target profit and discount factors. The numerator combines both factors. To maintain a specific profit margin after the impact of a discount, the initial markup must cover the sum of both the profit and the planned reduction. This sum is then divided by the value of 100 minus the discount. This step scales the markup against the actual portion of the sticker price that generates revenue. Retail pricing acts as a predetermined mathematical defense mechanism. It is calculated to survive the impact of future promotional cuts, while mathematically guaranteeing a profit. Once the initial price is set, it is actively manipulated through compounding multi-stage promotions. A common misconception assumes sequential discounts add together linearly to create a larger total discount. This notes page formalizes the equivalent discount formula, which corrects for the nonlinear scaling error present in successive reductions. The numerical example shows the logic in action. Taking 20% off and then an additional 15% off does not equal 35%. The critical intermediate step multiplies the two negative variables together. This creates a positive 3% offset against the initial negative 35% reduction. Successive discounting yields a true equivalent discount of 32%. This structural illusion protects the seller's margin more effectively than a single flat rate cut. The abstract concept of percentage discounts extends into physical inventory promotions, such as buy N items, get M free. Physically grouping free items alongside paid items is mathematically identical to applying a flat percentage discount across the entire combined volume. The algebraic translation at the bottom of the page proves this. The true percentage discount simply equals the free subset divided by the total transacted volume. Physical product giveaways are another geometric manifestation of standard discount algebra. Stepping back, we can view the entire mathematical model of retail pricing in action. All forms of consumer reduction, whether simple percentages, successive compounding drops, or physical article giveaways, collapse into a single negative vector operating against the marked price. The seller's required profit margin provides the inescapable opposing positive vector, anchored to the base cost price. Ultimately, the final transacted selling price is the rigid and predetermined mathematical resolution of these two opposing vectors. Every retail promotion operates within this same algebraic geometry. Understanding these equations provides a clear map of the internal logic governing any transaction.